Hi and welcome along to another repair video here. Today we're looking at an Atari Asteroids, one of two Atari Asteroids sets for Andy from Arcade Club. These are a couple that have been in the machine for a while, that's up there, and just need a bit of a service. This one is constantly resetting, which is a watchdog issue. Now let's dive straight in. The 5-volt side, the logic side of it, we'll deal with later, but one of the things you need to do with vector games, because the first one I've had a look at for them, first thing you've got to have a look at is all the voltages and everything, because it's a very difficult setup to look at unless you've got a full rig in front of you. All I've got is my old oscilloscope over there, which has got a little dot on the screen at the moment because I was just poking around and having a quick test play and everything before I started doing the video. Now, one of the first things that you do is you check your voltage regulations, and on the Atari schematic there is a nice section down here. It says power input, and so you work your way through that. And I know I've got 5 volts, I've tested that side of it, which is the regulated 5 volts. I've got my Jammer PSU over there, which I use for generally testing most boards and things like that. And I've got actually an Atari brick in my Ghetto Blaster setup, but I'm not using the AR3 for this because Asteroids only needs the 36 volts AC, which the brick supplies straight off. So that's enough at least for me to power the vector side. Now what it does is it breaks that voltage down, and it does it somewhere in this section here. It takes the 36 volt input, which is these 2 wires here on the harness, and it feeds it then through a bridge rectifier section here, through a couple of capacitors, and then through some voltage regulators. So you've got a 7815, a 7805, and a 7915 here, and somewhere else on the board that I haven't identified, which is going to be around here somewhere, you have a 7812 as well, which is producing 12 volts. The 79, for those who don't know, produces a negative voltage, but you've got to give it a negative voltage first. Anyway, enough about all that. So what I've noticed straight away, just doing a quick visual inspection and doing a poke around, is I don't have all the voltages I should have, and there was a capacitor here that was getting very, very warm. Now, let's pick this capacitor up. I've taken it out of circuit, and straight away I saw a hole in the top of the capacitor, so it's getting ready to basically blow its guts. Now, God knows what effect that was having on the rest of the board, but the board wasn't running properly. And I could just about faintly hear that's the desoldering rig in the background, occasionally sort of discharging and recharging its compressor. So there's a little hole there that started to appear in that capacitor. That wasn't helping, and I could definitely sort of feel some slimy residue coming off it, and it was getting very, very hot as well. Now, looking at the board down there, you can see some residue. Now, there's nothing that I can find wrong with this other capacitor. These are the main input power smoothing capacitors. What you have, if I go back to here, got your AC wiggly line coming in, and half of it goes through there and half of it goes through there. So the positive side's going through here, and it goes through there's a little 0.1 picofarad capacitor there, which is, I'm not sure exactly what its purpose is. I think that's, what's it say? There's a little note up here that tells you what it is. Bypass capacitors. Right, okay. Then it goes through a diode, CR11, and the output of the diode CR11 goes towards this one here, but then what you have is your other half of your 36 coming in here, because you've actually got realistically 18 and 18. It's 36 overall peak to peak. So you got, and then the other one comes up here and goes through there. So there's one half of 30 of it. The 2 diodes cause some voltage drop, and they're in parallel to each other effectively. Yeah, they are roughly. I can't be bothered to explain full wave rectification here, and I'm probably going to explain it really badly if I try. I know what I'm talking. I know what's going on in my head, but basically I've got voltage going through there, and you've got C87, which I'm not sure what voltage. I can't remember exactly what I had there. But down here, what I had was like hardly any voltage. And what I'm thinking is that because of the way that this is all arranged and everything, with these 2 capacitors, which basically end up as smoothing capacitors, so you've got your rail, it comes through and it gets half rectified, and then these basically pull it down and help smooth it off into a nice long line. So one of these wasn't right. What I'm going to do is I'm going to replace both of them though, because they've both been there since the year dot. It makes sense to do that. So I'm going to feed basically replace both of those, and then see what voltages I've got at that point. If I don't have the voltages right roughly at the test points, I mean, when it says plus 22 here, you know, 18, 19, 20, 21, 22, 23, there's perfectly fine. The same down here. You're never going to get it absolutely. They don't seem to have a turnout exactly like that. And then what I can do is I can test these voltage. What do you call them? The regulators. Sorry, here I was thinking about 14 sentences in front then. If I have correct voltages coming out here, which means I've got things like a plus 15 rail, and over here a plus 12 rail, and then a plus 5D VDAC, that's used, by the way, for the DACs. The digital analog converters, and then down here somewhere 7915, so I should have minus 15 somewhere in about here, which goes off to the rest of the board. And the plus and minus 15, by the way, on here are used for the vector side of it, if I remember correctly, or part that they're used for the amplifier side of the vector, so the bit that drives it. Your plus 5 is used for the digital analog converters, the DACs. Your 22 volt, according to the note up here, is used as part of the audio for the op amps, but and I'm not sure what the actual 12 volt circuit is used for on this board until I come across it. So I haven't really investigated much further than that. I don't think there's a note up here that says about the 12, 78,000. Yeah, it doesn't actually say in that note up there exactly what the 12 volt is used for. I would have guessed, I would have made a very wild guess that it was something to do with the amplifier circuit, but if it's using LM3, it's using LM324s, which generally means that you want a high positive voltage and a low negative voltage, so it's usually something like, in this case they're using plus 22 and minus 5. Anyway, we're getting off piste here. What I need to do is pop a cap in its vector circuit. Oh, sorry, bad jokes. I get told off by one of the viewers, oh, stick to the repair videos. I am sticking to repair, well, not just. You get what you're given, so like it, or, well, you know. Anyway, I'm going to stick a new capacitor back in there. I don't have exact spec ones. I have 470s, 470 UF, which is what that is. I'm going to put a slightly uprated capacitor in with 35 volts rather than just 25. So that's when I'm going to pop that in. I don't also have axial capacitors. I only have radials, so what I have to do is I have to get some heat shrink sleeving and just bend the pins around a little bit and make sure it doesn't short out on the ground plane there. Alright, that's going to be job one, and then we'll see what voltages we've got. Okay, I've now replaced the capacitor and ended up replacing all 4 diodes. There's probably nothing actually wrong with them, but I didn't think it would harm much to renew them as I was doing my debugging. Who's the silly boy then is actually the answer here to this problem. There's an issue that I hadn't even begun to consider, because I don't claim to know absolutely everything in the world ever, contrary to popular belief. But one thing I'd forgotten was that I'm getting 36 volts from over there, and all I was doing was bringing the 36 volts AC line down to the board, to these 2 red pins here. And I'm very used to working with AC voltages where your earth is purely just it's a protection circuit. So leaks to earth cause things to trip, etc., 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 to protect you from it. They're not a reference to it in that case. So I'm just not used to the fact that on what's effectively an AC circuit that I need a ground reference for it. However, apparently, and thank you very much to Raven, Mitchell Gant and Colin D on UKVAC for helping me out here. The problem is that the 36 volt AC is actually a centre tap transformer, and had I known and remembered that, I would have probably gone, oh yeah, you need to bring the ground across. However, I just saw it on the diagram as 36 volts AC, and the ground was looping to the AR on the schematic. So what I was thinking was, oh well, the ground's actually for the 10.3 volts DC unregulated input to the AR1, which then is used as along with the 36 to generate your 5 volt rail, which is what's needed to run the logic side of the board, the CPU and all the rest of the TTL logic over here. No. Okay. So anyway, what I've done is the purple wire that, for the observant of you, between the last scene and this one, is actually the centre tap of the 36 volt on the brick transformer from the Atari brick that's over in the back of the Ghetto Blaster thing over there. So that now comes down here, and this Z pin here is actually commoned to this this black pin over here, so A and Z, which are both ground, and then this ground here follows itself up to the jammer PSU's ground, so everything's grounded properly. And apparently what I had was that the diodes were working exactly as they should be. And it's just me being thick and I didn't quite understand all this, but the diodes were working exactly as they should be. But what you keep forgetting is that current, which is what gets drawn across a circuit, is attracted towards the next component. So if you just simply lift all these diodes up and point them in the air and then try and probe the ends of them, you're not going to see anything, or you're not going to see much voltage on, because there's nothing loading them, there's nothing pulling anything through. Had I pulled a resistor onto them across to, quite a decent resistor across to ground, and put a load on the end of that diode, I would have been able to see the voltage, and I should also be able to see it on the scope as well. But anyway, couldn't do that because I was just being thick, and really, I was just being pretty big, actually, thinking I could take on an Asteroids, but it's only a watchdog circuit. Easy peasy, we'll just chuck the fluke on there, bish bash bosh, nothing repair video, bet it's a 245 or a 244, aren't we big-headed? A lot of men's room big talking going on there, who's got the biggest soldering iron and all the rest of it. No, that's humbled me very slightly. Anyway, so if I pan across now very carefully, what we have on my scope is a vector output. That is test mode from an Atari Asteroids, and that's running with the watchdog disabled at the moment. And the reason I'm doing that is to make sure that this vector generation circuit is running. If I go over here and I turn up the volume on the speaker, you'll hear it beeping. A long continuous tone. If I take the watchdog disable off, that screen's going to start flickering. Yeah, and you could just about see the pattern in the background, because the watchdog kicks in, resets the CPU, because that's just not cricket, because the CPU should be running its game code normally. It's obviously able to access at least one of the ROMs on the edge in order to get far enough to a test pattern, and then crashing. So anyway, that will be the next part of our investigation, coming very shortly. Well, coming in a few seconds in real time to you. In my time, probably in a few hours when I've had something to eat, because it's getting round to sort of tea time as I look out across this magnificent vista of green foliage as we head towards autumn here in Blackburn. Anyway, so that's where we're at with the Asteroids board. I'm going to switch it off now and power off the vector circuit, and that hopefully should see the end of at least that side of the problem. And the good news is, though, with this, the good news is that all the vector generating amplifier circuit over here, which is all logic level, is all working absolutely fine, and the sound circuit's working fine. So literally the problem is just purely somewhere over here on the CPU circuit, and we know what things cause watchdogs to happen. It's usually it can't talk to the ROM, or there's a bad RAM. Now, my money is going to be something to do with ROM, because that Asteroids has a good test mode, which will try and tell you which RAM is the problem if it happens to be a RAM. And you get a series of beeps and things like that, and it'll come up into, usually without a test screen coming up, you'll just get a bunch of beeps. Now this is resetting, so I think that what's happening is it's getting as far as reading ROM 0, and then trying to access something. So either part of ROM 0 is corrupted towards the top end, or it's trying to read ROM 1 or ROM 2 and can't, or trying to access the vector ROM or something like that. Depends what the CPU can actually talk to, but it's unable to do that, therefore it can't get past the next bit. It's drawing that screen and it can't get past the whatever the test is. I would imagine, and if I remember, I haven't got the manual right in front of me at the moment, but if I remember correctly, the RAM test happens first, and then it draws that vector pattern. So I think it's able to talk to the RAM, and then it's able to talk to ROM 0, and it's going so far, and then what it's doing is it's trying to read switches and things like that, and it's getting hung up. So that's something, whatever the next step is in the progression along here, that's what's going on. So we're not going to waste any time. Fluke, big guns, they're coming out. Get that onto the CPU socket. We're not CPU's running because it's running code off there. It wouldn't be able to do that otherwise. So CPU is not my not my potential culprit here. Anyway, let's have a look what's going on. Some poking around has been done. It's now dark outside, as I promised it probably would be by this point. Poking around's been done. We've used the fluke. There's no point showing you that. We've been through all that process on a couple of videos now, so I'm not going to keep going through the same thing, repeating myself. Yeah, I'll do it in a few videos time again, but so go back and watch the centipede video and the missile command and things like that, and that shows you about using the 6502 pod and the 9010A troubleshooter. Right, so having a little bit of a look around the board. So the game's constantly resetting. I can read all the ROMs, I can read the vector ROM, I can talk to all the RAM, everything passes, but it's resetting. So the only thing you can do now is start poking around the CPU and making sure all the signals are there. So reset's obviously there because the CPU is continuously resetting, but the game's not doing anything if you disable the watchdog. So it's a bit interesting is that one, because I'm not really sure. There's a number of things that can cause it, and normally it would be inability to access all the ROMs and the RAM and things like that. In this case it can talk to all that stuff, or at least anything that it cares about. So what you do now is you start looking around the various signals. What I've done, but also I decided to use to do the whole old open the eyes trick and actually visually look around the board, and straight away I can see this chip here. Now I don't know about you, but if I just sort of zoom in on that very carefully, oh look, we seem to have a broken pin on it. Now that is C5. Now if I can zoom in a bit more and you can read the marking on it, it's a 161. That's board location C5. So zoom out. We'll have a look over here at this thing, and this is the NMI timer. So this is C5, it's an LS161 counter in the NMI circuit over here. Now I've just had a probe around it on the scope and there's nothing coming out of it, there's nothing present at the NMI point there. So, broken pin, it's on one of the input pins here, so unless this chip, I mean this chip could be dead anyway, which would, you know, that would cause it to have problems outside of test mode, and also if the watchdog is booting because the NMI is not kicking, and I'll bet the watchdog counter reset is on the NMI, and if the NMI is not running, then it would make sense probably that the game's resetting, because the NMI is basically like a train that's hurtling down a track at a gajillion miles an hour. You cannot stop it, and it will just keep calling its own service routine every so many ticks. Every so many pulses, basically, whatever the frequency output of this thing is set to. Now, with that pin not set, that's going to float high, because it's supposed to be pulled down to ground via that point there. So you've got 3, 4, 5 and 6 all pulled to ground. Sorry, 3 and 4 are pulled to ground, 6 is pulled to ground, but 5 is pulled up. So this is basically like an input signal to this counter, and says here's where you start from. And what we've got over here is we've got the negative test signal, and we've got the 3 kHz and a support resistor as well. So, well, I think it's time we replace that at the very, very least. Yeah, there's a reset signal going in there. Okay, let's replace that and see what happens, because that's definitely not going to help our cause if that's not running, the NMI is not running, because it wouldn't surprise me if most of the game code in the main bit of it doesn't run off NMI. 161 chip has been now replaced at C5, which is part of the NMI counter circuit. Now I got a bit of a red herring, because in test mode the NMI isn't firing. Take it out of test mode into game, and now it's definitely and it's firing. The chip was definitely dead, so we did the absolute right thing in replacing that, because with a broken pin it wasn't being grounded, so the signal that the starting count preset on that chip was never going to be right. It was always going to be floating around and probably generating some random crap. Anyway, so carrying on, we've got that now. It's out of test mode at the moment. If I take it back into test mode by putting that on, I think it's that one, sorry, excuse me. There we go. Right, so we're back in test mode now, and you can see it flickering like crazy like that. So the watchdog, so something's going on with the watchdog. We know it can talk to RAM, we know it's not the NMI signal now, so let's have a look a bit further back. And over on here on the schematics, what I'm doing is I'm looking at the watchdog circuit. One of the pearls of wisdom I got off Luke Wells, also known as Arcade UK, was always make sure your watchdog circuit's working correctly. So here we are in the watchdog. So what I'm looking for is the fact that when you have watchdog disabled pegged, so basically when you connect it to ground, one of the things that will happen is it will stop the reset signal being generated. But you still need the WDCLR signal over here, which is basically when the game writes to memory and it clears that that pulse. Now this is an LS00 at C6, so we'll start here. What we should see is we should see some signals going into there on 6, and we should see something going, should see probably a high signal actually, because the reset's now completed on 5. So let's have a look at C6. Now I've been having problems doing this without catching the grounding plane on my scope probe. So here's C6, so pin 1, 2, 3, 4. So there's your watchdog clear signal. There is the signal going to pin 5, which is coming from the reset, power on reset circuit. What I should see then is something on pin 6. It's an inverted signal. So, I'm not seeing anything. It's an active low. Oh, we're occasionally seeing a blip, but it's not enough. Certainly not on that. Right. So, I'm not happy about that. So let's load up. Let's get the comparator. And I still happen to have in the comparator a 00 card. Yep, LS00 from last time I used it a few days ago. So I'll take the comparator, I'm going to pop it over this C6, hopefully get it right. And it's telling me it doesn't like pin 3. Now, C6 and LS00, it's an inverted OR gate. It's going to have multiple gates on there. If it's arguing with me over pin 3, there's a chance that something else is using this C6 chip somewhere down the line that I haven't looked, and it wouldn't surprise me if that's the cause of it. We're going to replace that chip then in that case, because the comparator says that it's not happy about it. So let's do that. That LS00 has now been changed, socketed and popped in the board. And we've connected everything back up, and our test mode is now running properly. This will look weird and it will jump around a bit because this scope is pretty dead, to be honest. But it's doing what it should do. And if you notice you've got some extra lines, it's only because I haven't got the Z output, or the Z output if we're watching in America, hooked up. I'm going to take it out of test mode now. And look, we've got the game running. So you'll see the big, come on, stop jumping around. There you go. It'll jump about a bit, like I say, because this scope's a bit dead. But there we are. Game is back running. I could really do with having this on a proper vector monitor to really test what's going on. But the game's booting up now. Can't really say any more than that. I mean, it's flickering a little bit. I really need to see this on a proper vector monitor to figure out what's going on. Well, everything looks all right. Could be the wiring. Could be my wiring here. Could seriously just be this scope. Don't know. Not really seeing it doing much else. Yeah, it could well be this scope. This scope's a bit old and decrepit, but it does for vector output. I really should get the 10-inch monitor and figure out a vector brick power supply for it properly, or a decent AC transformer for it. And then be able to actually test vector games properly. You know, not a lot of people know I actually have a K6 100 sitting around on stock, which I've been saving for for another project, which is a colour vector. Might see if I can go and get that booted up, since we're having a bench changer, and it would be very useful to have a vector monitor in this setup properly. Right, just had the old dip switches up from the back door sheet, and it's now in English and in free play. Now it came to me in that mode, and what I've done is, as I've been poking around, I've hit the dip switches. They're only there. So if I tap the start, hopefully, yeah, I can hear and the destruction sound. There you go. Because I haven't got the Z output hooked up, and I might complete the rig actually. Sorry, the camera's moving all around here, it's difficult for me to look at the monitor and that. Oh, there you go. Game over. Well, it's good enough, that is, to prove to me that the game's working, so woohoo! Might finish the loom off before we send this back, and then I've got a board. Now I have another Asteroids board to work on, which has got some graphics output problems. I don't know whether I'm going to do a video on that. That's got some. That does start up, but it's got a slightly weird rock problem. I don't think it's the. What is it called? I don't believe it's the analog circuit over here, because it seems to be drawing the screen correctly. I'm pretty convinced it's the vector graphics side of it. So, as in the generator and drawing routines. Hope not, but I'm pretty convinced it is. Right, that's another one done. It's what time are we on? Oh, 10 to 1 in the morning, and yet another board for Arcade Club done. So they have an Asteroids that's working at the moment. This is actually this board is the one out of the one at the unit. The one that they're using at the moment is the one that's in the machine I usually take out to events with me. So it was worth me repairing the board anyway, and then we've got spares. So that's it. Well, hope you liked that little tiny trip and a bit of an explanation about AC circuits, and we also covered NMIs and watchdogs a little bit, and we covered debugging bad chips again. And now it's all just down to logic. I mean, all these things are just a glorified glorified computer. Basically, with some, they're a 6502, which, well, the same family, 65XX series, was in the Commodore 64, 6510 in the 64, and they're just basically a glorified computer with some specialised sound and video hardware. But that's realistically, you've got to kind of think of it in that way. I mean, it's a lot of fun to try and debug them. Anyway, if you haven't subscribed to the channel, now would be a fantastic time for you to just hit that subscribe button. It takes a half a second for you to do it. It's no effort, and if you like this kind of video, that means you're going to get notifications every time we post a new one. We're trying to grow the channel and bring you some new content and things, and watch out for Ben's show, Ben's Retro Rambles, which is hopefully every Wednesday. More episodes of that coming up. And you'll find all of our stuff on playlists on the channel. So go ahead, do give the video a like. Give us some feedback as well. If it's something you like, then do tell us. If it's something you don't like, also tell us, and we'll give you some sarcasm back as a response, because that's who we are. Anyway, until the next video in a couple of days' time, we'll see you all later. Bye.